Model-based thinking, using metaphors and mental models to unlock clarity and innovation. Introduction. In a world overflowing with data, decisions, and increasingly complex systems, clarity has become a rare and valuable commodity. Traditional problem solving often feels like trial and error, brute forcing solutions without a guiding framework. But what if we could shortcut this process by borrowing from something the mind already excels at? Enter model-based thinking, the practice of using metaphors and mental models to simplify the complex, frame the ambiguous, and solve the unsolvable. From ancient myths to scientific breakthroughs, humanity has always leaned on metaphor to make sense of the unknown. But today, we can formalize this intuition into a repeatable, high-leverage strategy. This exposition explores how metaphor, when chosen carefully and mapped with structural fidelity, can act as a cognitive scaffold. We'll introduce the Metaphorical Mapping and Solution (MMS) framework, walk through compelling use cases, and outline how you can turn abstract metaphors into real-world decisions. In doing so, we unlock not only clarity, but creativity and innovation. Why metaphors work. All understanding begins as metaphor. Aristotle. The power of metaphor lies in its ability to compress complexity into something the brain can manipulate intuitively. Neuroscience shows that our brains are analogy machines, constantly mapping new inputs onto known frameworks to make sense of them. That's why metaphors aren't just rhetorical devices, they're cognitive engines. Consider how we describe time. We spend it, save it, or run out of it, language lifted from economics. Or how we understand computer viruses through the lens of biological ones. These aren't just poetic flourishes, they're survival tools for navigating complexity. The key is structure-preserving metaphor, where the dynamics of the metaphor closely mirror the dynamics of the real-world system. This fidelity makes it possible not only to understand, but also to reason within the metaphor, and then translate back out actionable insights. Part 3. The core mechanics of model-based thinking. At the heart of model-based thinking lies a three-step recursive loop: mapping, modeling, translating. This triad allows us to borrow logic from a metaphor and apply it back into reality, like uploading a simulation to test drive a solution. Mapping, choosing the right metaphor. The first step is selecting a metaphor that mirrors the structure and behavior of the problem you're trying to solve. This isn't just about thematic similarity, it's about dynamic resonance. For example, if your problem involves constraints and permutations, the Rubik's Cube is a strong candidate. If it's about sequences of activation and intention, spellcasting or musical composition may be better. If it's about resource flow and bottlenecks, plumbing or power grids may serve as intuitive anchors. A good metaphor should have a one-to-one mapping of parts to the elements in your system, reflect similar feedback loops or decision dynamics, feel natural enough to reason within, even for non-experts. B. Modeling, solving within the metaphor. Once the metaphor is chosen and mapped, the next step is to reason inside its world. You don't yet need to worry about real-world applicability, just explore possibilities within the metaphor's logic. In a Rubik's Cube metaphor, you might explore minimum move solutions, rotation cycles, or edge freezing. In a spellcasting metaphor, you might explore how combining incantation plus focus plus timing yields powerful effects. If you chose a city traffic model, you might simulate how changing one intersection changes global flow. This is where play, intuition, and lateral thinking take over. The metaphor acts as a constraint, but also as an ideation accelerator. It frees you from the chaos of the real problem while giving you tools for structured experimentation. C. Translating, extracting real-world strategy. Now comes the bridge-building step, mapping the metaphorical solution back into the real domain. This translation requires careful unpacking. What do each of the metaphor's moves or rules mean in your actual context? A well-structured translator grid helps. Metaphor element, real-world element. Cube rotation, strategic decision, face alignment, team synchronization, God's number, minimum viable path to clarity, corner cubies, cross-functional actors. Ask, what does this metaphor suggest about sequence, efficiency, or friction? Are there leverage points you hadn't seen before? What insights can be tested rapidly or visually? If the metaphor was well matched, The translated insights often feel obvious in hindsight, but they weren't accessible before the mapping. Next up, IV, Case Study 1, Rubik's Cube as Team Dynamics. Imagine you're managing a high-performing team where every department, engineering, design, marketing, product, is technically capable but functionally out of sync. Strategy feels chaotic, coordination costs are high, progress stalls. You don't need more resources, you need alignment. This is where the Rubik's Cube metaphor becomes potent. A. Mapping team dynamics onto the cube. In this metaphor, each cubie represents a team member or subunit. Each face corresponds to a function or shared objective. Rotations represent decisions or strategy shifts that affect multiple layers at once. The Solve Cube is a fully aligned team where everyone is on mission and minimally reactive. Key insight: you can't move one piece without affecting others. Every rotation has second and third order effects, just like real decisions within complex organizations. Working within the metaphor. Inside the cube logic, we explore algorithms, predefined sequences of moves that achieve specific goals. These might represent playbooks or workflows. God's number, the minimum number of moves required to solve any scrambled cube, 20. As a metaphor, it implies that clarity may be closer than it seems if only we know the optimal path. Corner orientation. If a corner piece is rotated wrong, it throws off the whole puzzle. In the team metaphor, corner cubies could represent high-leverage individuals. If they're misaligned, nothing else clicks. By thinking in cube logic, you begin to see which decisions create unnecessary churn and which are surgical. You learn that speed isn't just about motion, it's about precision. C. Translating the metaphor back. From this metaphorical modeling, we extract actionable strategies. Cube insight, organizational implication, rotations affect multiple layers. Every decision influences multiple teams. Optimize sequencing, solving the cross first. Focus first on foundational alignments, e.g. shared metrics. Corner QB misaligned. A single high-leverage individual out of sync can block flow. God's number. There's likely a minimum viable reorg. Don't over-rotate. This metaphor turns abstract dysfunction into a solvable configuration problem. It suggests you don't need more meetings. You need fewer, better sequenced moves. You don't need to motivate the team. You need to restore structural alignment. V. Case Study 2. Spellcasting as programming with LLMs. As artificial intelligence, particularly large language models (LLMs), becomes increasingly embedded in how we think and work, a new mental challenge emerges. How do you reason about a system that is probabilistic, non-deterministic, and language-driven? Traditional programming metaphors, logic gates, data structures, APIs, often fail to capture the fluidity and creative potential of prompting. That's where the metaphor of spellcasting becomes uniquely useful. A. Mapping LLM prompting to spellcasting. In this metaphor, the LLM is your spellbook or arcane engine trained on vast ancient knowledge. The prompt is your incantation, a carefully structured phrase or ritual that channels the model's latent power. Modifiers, temperature, context window, role setting, are ingredients, changing the spell's effect. The result is a magical manifestation, a completion that reflects your intent, syntax, and skill. Key insight: you are not coding a machine. You are coaxing an intelligence, one that responds to mood, structure, and framing. The art is not command, it's casting. B. Reasoning within the spellcasting metaphor. Using this frame, new behaviors and best practices emerge. You don't shout orders, you compose rituals. You don't debug with breakpoints, you test spells iteratively. You don't assume consistency, you anticipate enchantment drift, where results subtly change with phrasing or sequence. It also reveals advanced prompting as a kind of grammar of power. You begin thinking in stacks, chaining multiple spells, e.g. function calling, reflection loops, summoning circles, using memory tools, mod filters, or assistant personas, amulets, reusable prompt templates, or prompt components like spell scrolls. Translating the metaphor back to practice. Through the lens of spellcasting, practitioners shift from treating LLMs as deterministic tools to engaging them as pattern amplifiers, mirror chambers, or creative familiars. Concrete changes in practice might include spellcasting insight, prompting practice. Syntax shapes the spell, Even small word changes matter. Test phrasing rigorously. Rituals benefit from structure. Use templates, preambles, and progressive disclosure. Magic reflects intention. Clarify what outcome you want before you prompt. Spells degrade if overused. Vary prompts to avoid hallucination or pattern lock. This metaphor gives new users confidence, intermediate users nuance, and advanced users a sense of craft. It frames prompting not as using AI, but as participating in a living dialogue with logic. This content is brought to you by Bobby Giggs. Promote your brand here and reach a wide audience across platforms like YouTube, Instagram, and Facebook. Follow the links in the description to get started. VI, Developing an MMS Toolkit, Metaphorical Mapping and Solution. Having explored two high-leverage examples, we now ask, how do we make this repeatable? The answer lies in MMS, Metaphorical Mapping and Solution, a flexible, logic-anchored framework for applying model-based thinking across disciplines. The toolkit breaks down into 5 operational stages, each with supporting heuristics and guardrails. 1. Define the problem clearly. Before reaching for any metaphor, articulate. What system are you dealing with? What outcome would count as solved or clarified? What elements, forces, or constraints must be honored? Tip: avoid metaphor too early. Naming the real problem first keeps your metaphor from becoming a crutch. 2. Select a high correlation metaphor. Criteria for choosing a metaphor: structural resonance. The metaphor shares a similar number and type of components. Dynamic symmetry. The behaviors or feedback loops in the metaphor match the real systems. Intuitive fit. The metaphor feels playable in your mind. Generative, not confusing. Example options: real-world system, candidate metaphors, resource allocation, plumbing, circuit boards, traffic flow, organizational friction, gears, sand and machinery, musical rhythm, software refactoring, urban renovation, pruning a bonsai. 3. Build the mapping grid. Once selected, construct a metaphor reality grid. Metaphor element, real-world element, nodes, departments, flow, communication speed, blockages, misaligned incentives, valves, decision checkpoints. Also capture which elements are controllable, which are emergent, where metaphor diverges, not everything will match, possible blind spots, the metaphor might obscure. 4. Solve within the metaphor. Now enter the metaphor. Play inside its logic. Explore what happens when you tweak elements, reverse flows, or accelerate loops. Identify elegant solutions or compression paths. Don't worry yet about feasibility. You're looking for shapes of solutions. Translate the solution back. Re-express metaphor-driven insight as real-world steps. What does each metaphor move mean in your actual context? Are there sequences or leverage points you hadn't seen before? Does the metaphor highlight what to stop doing as much as what to start? Use tools like scenario walkthroughs. Test decisions as if they were metaphor moves. Role reversals. Flip metaphor roles to see from another perspective. Inverse modeling. Imagine the worst outcome and reverse engineer it using metaphor logic. Optional. Validate and iterate. Before committing to action, run the metaphor past others to surface blind spots. Try other metaphors for triangulation. Stress test the solution in low-stakes environments. Final check. Ask, did the metaphor increase understanding, reduce noise, and reveal new options? If not, discard or refine it. 7. Implications and applications. The power of model-based thinking isn't limited to thought experiments or creative brainstorming. When operationalized through MMS, it becomes a cross-domain tool for clarity and innovation, especially in environments of uncertainty, overload, or systemic ambiguity. Here are key domains where MMS shines. A. Decision-making and complexity. In volatile contexts, startups, policy planning, crisis management, clarity is often blocked by noise, competing incentives, or paralysis by analysis. A well-chosen metaphor cuts through by offering visual reasoning. See the system in motion. Leverage discovery. Spot where small changes shift the whole. Moral clarity. Frame trade-offs in language that resonates. Example, using a symphony orchestra metaphor to structure a product launch, each team as an instrument, the timeline as a score, and the product manager as conductor, reveals where discord arises and how to regain tempo. B. Design, innovation, and prototyping. Metaphor is a generative constraint. It limits arbitrary freedom and forces creative structure. In design and R&D contexts, MMS can reframe user needs through anthropomorphic or ecological lenses, generate radical design ideas through sci-fi metaphors, test UX flows using metaphors of movement, architecture, or game logic. Example, metaphorizing an app interface as a physical workshop led to a design that replaced drop-down menus with tool walls and tactile drag-and-drop flow, improving usability and reducing cognitive load. C. Education and knowledge transfer. Teaching complex ideas becomes far more effective when learners can anchor abstract ideas to lived or metaphorical experiences. Mathematics as music, chemistry as social dynamics, algorithms as spells or recipes. MMS gives educators a map for metaphor selection based on structural fidelity, making lessons both sticky and rigorous. Cross-disciplinary synthesis. In innovation labs, think tanks, or interdisciplinary teams, the unifying logic of metaphor bridges language gaps between fields. Biologists and engineers can use ecosystem metaphors to co-design synthetic biology tools. Economists and software architects can use market metaphors to co-develop token systems. Artists and machine learning researchers can explore creativity through a shared lens of improvisation. MMS acts as a common protocol for collaboration, allowing each participant to bring their native lens without losing shared structure. Conclusion. Metaphors are not decorations. They are tools, cognitive scaffolds that let us see, reason, and build in spaces that would otherwise remain opaque. When selected with care and used with discipline, metaphors don't just explain the world, they help us reshape it. Model-based thinking, operationalized through the MMS framework, gives us a way to structure thought in environments of chaos, invent options where none seemed available, translate insight from imagined domains into real-world strategy. Whether it's using a Rubik's Cube to realign a team, casting prompts like spells to reason about AI, or mapping economic dynamics through ecosystems, the logic is the same. Build a model, solve inside it, then translate back with precision. In a world increasingly driven by abstraction, noise, and overload, the metaphor becomes a map, and the person who can read it gains not just understanding, but leverage. So next time you face a problem that feels intractable, don't ask, "What's the answer?" Ask instead, "What's the right metaphor?" Because once you find it, the answer often writes itself.